Here we are in the software, and we're starting off this lab activity by communicating over the Ethernet connection to our MOVIDRIVE to commission this new application module. And we're also starting with parameters from Lab 9, Part 2. If you remember from Lab 10, we backed up those Lab 9, Part 2 parameters. We demonstrated the keypad features and then re-downloaded the parameters back to the MOVIDRIVE. So that's where we're currently at. And if we right-click on our MOVIDRIVE and then go to the parameter tree, and then go to iPOS information, we can see that table positioning is still the application module that's loaded. And to change the application module, we don't have to factory reset the MOVIDRIVE and start from scratch. We can just overwrite the existing application module with a different one. So let's go through doing that. So we can close this parameter tree. And then before we start our application module change, we need to change the name of our device for this new lab. And if you remember from Lab 9 Part 2, if we change the name of our online device right now, it's going to change the offline project device name as well. And we don't want to do that because that's going to change the parameter backup that we have from Lab 9 Part 2, which we don't want to lose those parameters. So let's go ahead and create a copy of those. So we will go right-click and then choose Create Copy. It's going to propose a new name, and I'm fine with that. We'll say OK. And then there we go. Now we have a duplicate copy of our parameters from that lab. Now let's change the name of our MOVIDRIVE. So we can right-click on it, and then go down to Properties. And then let's call this MOVIDRIVE MDXB Bus App for the Bus application module, and click OK. And we can see it now changed the name of our online MOVIDRIVE, and then it also changed the project backup that we have. So let's go ahead and come back to this table app _2, right-click on it, and go to Properties, and then delete this _2 so we can put it back to the name it was before, and then say OK. It's going to say there's files that exist with that same name. Am I sure I want to overwrite it? And I'm fine with that. Yes. And then it reminds me for a different file, and I'll say yes. There we go. Now we are ready to start this application module because we have a backup of Lab 9 Part 2 still there, and now we are prepared to do the new application module. So let's come down to our MOVIDRIVE, right-click on it, and come to Application Modules. And we are going to be doing bus positioning, but if you need more process data than bus positioning offers, the other option is extended positioning via bus, which is very common, and that's what I showed in the presentation. But we're not going to be demonstrating this application today, so let's go back to bus positioning and click on this. It takes a second to open. And this first pop-up screen is reminding us that there is a help file that we can click on this yellow question mark if there are any questions about the startup or operation. So we can say next to acknowledge that. And then the application module did not open to the monitoring screen. It opened to the commissioning screen, and that's because the software knows that this application module is currently not loaded to the MOVIDRIVE. So it knows not to jump into the monitoring screen because we need to commission it first. So the first screen of the commissioning that we need to set is the type of field bus we're going to be using with this application module. There are some options here, but for today, we're going to be setting this to Ethernet. It grays some boxes out that are not valid for that type of field bus, but it leaves this timeout response, and it's currently set to rapid stop and warning, but there are other options here as well. These different settings will configure how the MOVIDRIVE should respond if the field bus were to time out. The items that say fault mean that a fault code is generated and it will have to be manually reset before operation can resume. The items that say warning mean that operation would resume automatically without a fault reset once the communication is reestablished. So we're going to leave this to rapid stop and warning. Then now we can click the next button. A lot of these parameters will look very similar to what we saw in Lab 9 Part 2. So I won't go into a lot of depth here on each one of the parameters that we've seen before, but if you need an explanation of some of these parameters, then you can go back to Lab 9 Part 2 where I explain them more completely. So starting from the top, we have the source of the actual position, and we're currently still using the motor encoder, but there are other options for an external encoder or an absolute encoder, but we're only connected to the X15 port of our MOVIDRIVE, so we'll leave it to that selection. Now we come to the box where we calculate our distance scaling. There's still options here for a driving wheel or a spindle slope. We're still using a driving wheel, so we'll leave it selected to that one. And then the diameter of that driving wheel is 120 millimeters, so I'll type in 120. And then our unit millimeters is off to the right, but there is a new option here for tenths of a millimeter. So if I needed more accuracy than a millimeter, I can change this unit to tenths of a millimeter. But if I do that, I also have to add a 0 because our measurement for tenths of a millimeter would be 1200, not 120. So if you do change this unit over here to the right, make sure that your integer in front of it is correct for that unit. Our driving wheel is measured in 120 millimeters, so we're just going to leave that to millimeters and then change this back to 120. We still do not have a gearbox or any external ratio on this demo motor, so we're going to leave this 1:1. But if there was a gearbox or a sprocket or some type of external ratio, then we would need to correct this to those values. Now we have a new option for unit for the speed, and this is for the speed scaling. So that way, if you don't want to set RPM and you want to set a different unit from your PLC, you can do that. If I click the drop-down menu, we will see that there is millimeters per second, meters per minute, or 1/minute, which is the same thing as RPM. For this lab, to keep it simple, we're going to leave this to 1/minute for RPM. And then now I press the calculation button, and we get a scaling factor that converts our encoder increments into a millimeter based on the information that we've loaded so far into our scaling factors. Now, if we had changed the unit for the speed to, say, for instance, millimeters per second, and then pressed calculation, it would have also loaded a scaling factor down here, which would convert RPM into this millimeters per second unit. But we're not going to be doing that for this lab activity. But just like I mentioned in Lab 9 Part 2, you can enter in a custom unit for the distance and the speed, but it is your responsibility to make sure your conversion equation is correct for that custom unit. So we're going to change this back to RPM and then press calculate, and it puts that back to 1:1 and then 1/minute divided by 1/minute. So that way there's no conversion. So we can go ahead and click on next. And we'll set the software limit switches to what we used previously, which was negative 21,000 and positive 21,000 millimeters. We are still using the hardware limit switches, so we will leave this to yes. The reference offset, we're going to leave that to 0 since we're not using it. And then the reference travel type, we're going to change this to type 8. So we'll scroll through here until we find 8. There we go. And then now we have some ramp values that we did not have before, and that's because in Lab 9 Part 2, we set a different ramp and speed for each of the positions that we programmed. Since we aren't programming positions ahead of time in this application module, we only have 2 ramps to pre-program. So for ramp 1, let's leave that to 1 second, but for ramp 2, let's change that to 4 seconds, and then press enter, and we'll see that it changes these grayed out boxes as well, which is just the conversion between millimeters per second squared and then the seconds value. Going further down, we now need to set the maximum values for the application module. So the first box asks for the maximum motor speed for automatic mode. So let's set that to the maximum rated speed for this motor, which is 1800 RPM, and then press enter. And then now we get this red box. And the reason we're getting this red box is because this RPM is currently higher than the maximum allowed for the speed controller, which is currently set to 1500 RPM. And the way this parameter works is it has to be 10% higher than any of these max motor speed in automatic or max motor speed in jog mode parameters. So if I want to set 1800 RPM for automatic mode, I need to set my NMAX speed controller to 2000 RPM. And then press enter, and we'll see now that red box goes away. And the reason that I set 2000 RPM here is because 10% of 2000 is 200. If I subtract 200 RPM from 2000, I get 1800 RPM. So that's how I'm allowed to set a value at 1800 and then set the speed controller to 2000. If I change this to 1801 and then press enter, you see the red box comes back. Say, for instance, I didn't want the speed controller to be higher than the rated speed of the motor. So let's change this to 1800 RPM. And then now, using that same 10% equation, if I need to be 10% less than this for any of these parameters, 10% of 1800 is 180 RPM. And if we subtract 180 from 1800 RPM, we get 1620 RPM. So that means I can set this to a maximum of 1620 and then press enter. You see, if I go to 1621 and press enter, the red box returns. So the 10% equation is 10% of the speed controller, not 10% of these values here. So just know that if you see a red box, it means that your speed is too close to the speed controller maximum allowed. Let's change this back to 2000 RPM and then change this back to 1800. And then we will say our maximum motor speed for jog mode will be 500 RPM. So let's change this to 500 and then press enter. And then now that we have this set up and there are no red boxes, let's go ahead and press the next button. It asks, do I want to save the current changes? And like I mentioned in Lab 9 Part 2, you're not required to save this file to load it to the MOVIDRIVE, but it could be helpful if you want to view these parameters offline and you're not connected to the MOVIDRIVE, or if you're setting up multiple MOVIDRIVEs that will use the same configuration. So that way you don't have to manually set this up each time. So let's go ahead and just save it. So we'll say yes. It goes ahead and puts it in the folder that we created, MDXB bus app. So that's why we changed the device name in the beginning, so that it created a folder for us to use in the Motion Studio project. And we can name this file bus app and then V1 for version 1. And we'll say save. And then now that file is saved. And just to show you where that file was stored, we can pull this out of the way, come to our Motion Studio folder, and then go into Devices. And then we will find Bus App, which is right here. And then there is the file that we just saved, Bus App V1. And you'll still see that there is a table app V1 in here, and that's because we overwrote the name, and so there are some existing files within this folder. Since we just changed the name is all we did. We didn't create it from scratch. So that's why you're still seeing a table app V1 there as well. But you can delete that from the folder manually if you don't want to see it. But that is the file that we just created. So let's close out of this and then come back to Motion Studio and come back into our commissioning screen. Okay, and then now we need to press the download button to actually get this file into our MOVIDRIVE. So we'll press download. And now it asks to go into the monitoring screen. So let's go ahead and do that. So I will say yes. And then here we are in the monitoring screen of bus positioning. And just from the presentation, you can see that the top of the screen is for the traffic going to the MOVIDRIVE and from the MOVIDRIVE. The left side of the monitoring screen is for information that we would use to control the MOVIDRIVE. And then the right half of the screen is status information back to us about how it's being controlled, the current speed, and the position of the motor. And if you look towards the top of the screen, you can see that monitoring mode and control mode is grayed out, and it's not allowing us to change between them. And the reason for that is because we are connected over the Ethernet field bus to the MOVIDRIVE with this application module. To use control mode, we actually need to use our USB to serial converter cable to allow us to go into control mode. Now, I will mention that not every application module has this requirement to use a serial cable to go into control mode, but specifically with positioning via bus, it does have that requirement. So if we want to control it from the application module screen, we need to be using a USB to serial converter cable. But if we didn't have the serial cable to go into control mode, in a real application scenario, we could control it from the PLC program and still use the monitor mode of this application module to verify that the correct information is being sent. But since this demonstration doesn't have an upper level PLC, we will need to use control mode of the application module. So let's go ahead and switch over to our USB cable. So we can close this application module screen. Now let's come over to our connection and then right click on network and choose communication. Let's change it to serial. And then we'll choose edit. And it already detects that COM port 5 is the one that has the USB cable on it. But if it didn't automatically detect that for you, you can scroll through your list and look for the COM number that has USB in parentheses. So we'll just leave it selected to that one. We'll leave the baud rate to auto and say OK. And then click OK. It's going to change this Ethernet node to serial. So I'm going to say yes, I want to continue. And then there we go. It's changed the node. Let's right click on serial and choose network scan. And then there is our MOVIDRIVE B. Let's go ahead and right click on it and reopen the bus positioning module window. And here we go. Now we are switched over to our serial cable. And you can see now that monitoring mode and control mode is selectable. Before we switch into control mode, let me show you the bottom of the application module screen where it shows our digital inputs. And these are important because even though we are sending the majority of our control information over the bus network, there are still digital inputs that are required by the MOVIDRIVE. So let's pull this screen over to the side so we can look at our digital inputs. So let's go ahead and turn on our controller inhibit input, turn on our hardwired enable, and then let's turn on both of our limit switches. And then now we can switch into control mode. And we get an error message. And it says controller inhibit not active. So just like you would have an error message if you tried to switch into manual operation, if your controller inhibit was cleared, this application module will also require you to have your inhibit terminal turned off to be able to enter and exit monitoring and control mode. So let's go ahead and turn off our inhibit terminal. And then let's click the OK button and switch into control mode again. And you can also see here at the top, now that we're in control mode, it changed the communication method of the application from Ethernet to RS-485, which is how the serial cable communicates to the MOVIDRIVE. So let's go ahead and turn on that inhibit terminal again. So the left side of the screen is information that we need to set to control the MOVIDRIVE, and the right side of the screen is information back to us about its status and its current speed and position. So if we look at the status, we can see that the inverter is ready, but the IPOS is not referenced. So since we're currently not referenced, the first thing we should do before we try to operate this application module is reference our equipment. And we can see down here at the bottom, it's currently saying our position is at 17,554 millimeters. And then this green arrow is pointing somewhat close to our software limit switch in the clockwise direction, which we set to 21,000 millimeters. To reference the MOVIDRIVE, we will be using this P01 control word and then set the individual bits to tell the MOVIDRIVE that we want to go into a reference mode and then do a reference routine. From the presentation, I pointed out that if you click the green circle, it will turn that bit on, and if you click it again, it will turn the bit off. I do want to mention that control mode of this application module screen will operate slightly differently than using a real PLC. And the reason is because when you click one of these bits on, it does not automatically happen in the MOVIDRIVE. It requires you to press the Send PA button anytime you want to make a change to the bit assignment of the control word, the set point speed, or the target position. So even though that I have selected these bits, it is currently not in the MOVIDRIVE yet. I have to press that Send PA button. So when you are using control mode of the application module screen, you do need to be very careful because there is going to be a slight delay and response by you having to turn the bit off and then pressing Send PA to either stop the application, change the speed, or change the position. Okay, so the next thing I need to point out is the mode bits. If you remember from Lab 9 Part 2, Over on the right-hand side of the screen, there is a key telling us what the mode bits were and then how we can get into different modes using 2 digital inputs. We don't have a key for this application module screen that's shown right here in the top, but it is over here underneath these 2 bits, and then it currently shows reserved. If you hover your mouse over this, it will give you a pop-up telling you the different bit assignments to get into the different modes. Now, reserved just means that no mode is currently active, and this pop-up does time out on you, so you will have to keep pulling your mouse off and then putting it back over this text to get it to pop up. But there is an alternative to determine your mode. Since we're in control mode, we can click these bits and not actually do anything in the MOVIDRIVE until we press the Send PA button. So we can click this first bit right here and see that that would activate jog mode. We can turn that off and then click this second bit, and then we see that is the reference travel mode. And if we turn both bits on, that is automatic mode. So that's a quick way to determine your modes without having to look at the key. So let's turn these both bits off, and let's reference the MOVIDRIVE. And the way to do that depends on the reference routine that you selected during commissioning. We chose type 8, which means it does not require the enable signals, and it's just going to reference currently where the motor is sitting. So we will not see any movement of the actual motor to do the reference. And we can also see that our set point position is still 17,554 millimeters, but that will change once we do the reference routine, and then this IPOS reference bit should come on. So let's do the reference routine by turning on the reference travel mode. Let's go ahead and just press Send PA for that to activate the mode in the MOVIDRIVE. And then now all we need to do is just send the start command. So we will toggle on the start bit and then press Send PA. And now the MOVIDRIVE is referenced. We can see we got the IPOS reference bit turned on. The set point position changed to 0 millimeters. And we're also getting a status bit for the target position reached. And the reason we're getting that is because the target position is currently set to 0 millimeters. And that's also right where we're at. The next thing I want to demonstrate is how to jog using the control mode of this application module screen. So let's turn off our start bit and then our reference travel mode and send that to update it in the MOVIDRIVE. And then to jog, we need to put it into jog mode. We also need to activate both enables. So that's this bit here and then this one. And let's go ahead and send that really quick. All right, we can see that we have now enabled the MOVIDRIVE. It tells us that the technology option, which just means that there is an IPOS program running, is active, and the brake is released on the motor, but we're currently not moving yet, and that's because we haven't given it a jog direction or a speed. So let's give it a slow speed of 25 RPM, and let's just jog plus, and then now once we press Send PA, the motor should move, so let's test that. There we go, the motor is now slowly moving to the right. Let's give it a faster speed of 100 RPM. And then you can see the motor has not changed its speed yet because I haven't pressed Send PA. So let's press Send PA to update the speed. Now we're moving a little bit faster. Let's try the other direction. So we need to turn off jog plus, turn on jog minus, and then now we can just update that. And now the motor is reversed and going the other direction. Let's go a little bit faster. So let's go to 500 RPM, which was our maximum speed for jog mode, and let's test that. Now we're traveling, and it's approaching the negative software limit switch. Let's see how it responds as we keep getting closer. All right, jog mode automatically stopped a short distance before the software limit switch. Let's test the other direction. So we will now turn off jog minus. Let's go jog plus, and let's try to go faster than our limit value. We set our limit to 500 RPM. Let's just try to go 750 and see what happens. So let's go ahead and press Send PA. And it's now traveling, but we can see that our set point speed is only going 500 RPM. It ignored our 750 RPM set point because we limited our jog mode to be no greater than 500 RPM. And then now it automatically stopped just slightly before our software limit switch, which we set to positive and negative 21,000 millimeters. Okay, let's go ahead and just take it back to a target position of 0 millimeters. So I will slow the speed down. And let's just jog minus and see if we can get close to stopping at 0. Once we get inside 10,000 millimeters, I will slow the speed down. Because of the delay, I will prepare for that in advance and go ahead and send this change. And it's slowed down now. And to stop the jog mode, I need to prepare in advance to either remove the jog direction or remove one of the enable signals. I don't want the brake to engage right now, so I will just remove the jog direction first to bring the motor to a standstill and press send PA. Now that we're stopped, I'll just remove one of the enable bits to engage the brake. What if we wanted to move past our software limit switch? Well, just like Lab 9 Part 2, we have a bit that is dedicated for that, which is this last bit over here on the left, which is the acronym for Software Limit Switch Disable. So let's try to move past our counterclockwise limit switch since we're already heading in that direction. So I will activate this bit. Then let's go to a faster speed of 300 RPM. And let's make sure we're going jog minus. And we can go ahead and send that. And it's not moving yet, and that's because we have not activated this enable bit. So let's go ahead and just activate this enable bit and then send this now. Now it's traveling and up to speed. I will plan in advance and turn off this jog minus bit. Now we're past the software limit switch, so we'll update the process data to stop the motor. And we have not faulted out because we have this software limit switch bit turned on, which deactivates that function. So let's go the other direction by going jog plus and then press send PA. And the green arrow will come back into range here soon. There we go. And then now we are back inside of our software limit switches. And if we want to stop it, we can just turn off the direction and press send PA. I do want to mention that if you happen to remove your enable signal and you are outside of your software limit switches, it will cause a fault. So if I demonstrate that again, let's go minus and then press send PA and go back outside of our software limit switch range. And if I decided to remove the enable signal to stop the motor, press send PA, and then let's re-enable it for the other direction and press send PA. We caused a software limit switch approach fault. And that's because we removed the enable while we were outside of the software limit switches. To get clear of that, all we need to do is just go ahead and send this reset fault bit. Make sure we're going in the opposite direction of the software limit switch. So we will be going in jog plus to go back towards 0. And then now we still have the software limit switch disabled bit turned on. So let's send that. There we go. And then now we are clear of our software limit switch fault and we're bringing our motor back into range. So we can go ahead and just turn off the jog plus bit, turn off this reset bit, and then send that. Okay. And then we can also turn off this software limit switch disable bit and then send that again. And then let's remove our enable signal. The next thing I want to show you is how automatic mode works with positioning. So on the screen here, we have a table of different positions. So let's go through this table and achieve each one of these positions, ramps, and speeds. So the first position we want to go to is 20,000 millimeters. So let's type in 20,000. And that will be a speed of 500 RPM. And the ramp for that one is a ramp of 1 second. And the bit we use to switch between the ramps is this bit right here. And it's before the software limit switch bit that we were just using. And currently, with the bit off, we are using ramp 2, which means the 4-second ramp we programmed during commissioning. If we turn the bit on, then we will be using ramp 1, which is the faster 1-second ramp. So this first position calls for the 1-second ramp. So let's leave that bit on. Let's turn on automatic mode. And then let's give it the enables and then press send PA for that. Now the brake is released on the motor, and we can see that with this brake released output bit here, it's turned on, but the motor is still not moving, and that's because automatic mode requires this start bit before it will do anything. So let's go ahead and just toggle on the start bit and then press send PA. And it's now traveling to 20,000 millimeters. and it stopped right at 20,000 millimeters. Okay, let's try the other direction, which is negative 20,000 millimeters. So I will turn off the start bit, and then let's just change it to negative 20,000. Press send PA on that. But this position is a little bit different because it requires a ramp of 4 seconds. So I need to turn off this ramp bit here and switch over to the 4-second ramp. And then now I can turn on the start bit. But I also can't forget that this is going to be using a different speed. So this is at 1800 RPM. So let's change this speed to 1800 RPM. And then now let's press send PA for that. Now it's traveling at a much faster speed to negative 20,000 millimeters. And we are in position. Okay, the next position is asking for 10,000 millimeters at 1 second and 800 RPM. So we will change it to 800 RPM, 10,000 millimeters, 1 second ramp. So we need to switch back to ramp 1. And then now we can just send that again. And it's traveling to 10,000 millimeters. Okay, let's try negative 10,000. So negative 10,000 with a 1 second ramp, so that ramp bit will not change. And then 1200 RPM, and then send that again. Okay, and you can see through each one of these, I'm not having to toggle any of these bits on and off unless I need to for certain scenarios. Right now, we're just changing the position, the ramp, and the speed, so I'm able to leave the start bit on, the enable bits, and the automatic mode bits, and it's fine. So let's test position number 4, which is asking for 300 RPM at 500 millimeters, and the ramp will be 4 seconds, so I need to turn off this ramp bit, and let's send that. And it stops in position. Now for this last position we need to test, it's asking for a position that is outside of our software limit switches. So let's test and see what happens with that. So we will change our speed to 1950. And then the ramp needs to be 4 seconds. So we will leave this bit turned off. And then let's test negative 22,000 millimeters. And press send PA. And we immediately get a software limit switch approach fault. And that's because the application module knows that if we actually travel to this position, we will be traveling past our software limit switch, which isn't allowed. So even though the motor is nowhere close to that software limit switch, it goes ahead and issues a software limit switch fault, letting us know that this target position is not valid. So let's change this to the actual software limit switch. So let's just change it to negative 21,000 millimeters. And then also, we are setting a speed of 1,950 RPM. If you remember from the commissioning, we limited automatic mode to be 1,800 RPM. Let's see what happens if we program a faster speed than we set our maximum to. So we need to first reset this fault. So let's just turn off the start bit so nothing moves and send this reset fault command and press send PA. There we go, the fault is now reset. Now if we turn on the start bit, let's see if we can achieve 1,950 RPM. So I will press send PA. And that was too short of a distance for us to reach our set point speed with a ramp of 4 seconds. So let's go the full distance now of our travel range. So let's go to positive 21,000 millimeters. So we'll press send PA. And we're up to speed, but you can see briefly there that we only got up to 1,800 RPM. It did not allow us to achieve 1,950 RPM. Let's test that one more time by going back to the other direction and then send that. And there we go. We can see we're at 1,800, but we're not accelerating any further. Okay, let's go back to the 0 position, and we'll change this back to 1,800 and then send that. Okay, let's demonstrate what happens if we contact one of our hardware limit switches, which is DI04 or DI05. Throughout the lab so far, we haven't needed to switch the digital inputs to control the MOVIDRIVE, but they are required, so we can't turn them off. But let's go ahead and just test what happens if we contact one of our limit switches. So let's give this a slow speed so we have time to respond. And we can type in 20,000 millimeters. And I should have turned off the reset fault bit after we cleared from that last fault, but I'll turn it off now. And let's send that. And let's simulate contacting our clockwise limit switch. There we go. And we caused a fault. So just like Lab 9 Part 2, this application module also has a feature to allow the motor to back off of the limit switch, so that way we don't have to try to jog in a direction away from the limit switch. So let's test that by turning off the start bit and then both automatic mode bits, and then send that. And to move clear of the limit switch, we actually need to be in a jog mode. And you can see right now we're currently in reserved, which means no mode active. So this is what makes it a little bit different than Lab 9 Part 2, because the default mode in that lab was jog mode. With this application module, reserved is the default mode. So we need to make sure we turn on jog mode. We have both enable bits turned on, but we also need to send the reset fault bit. And then let's go ahead and send that. There we go. And now the fault has been cleared and is telling us we're still on the limit switch, but the motor is slowly backing off away from the limit switch. So let's go ahead and simulate that switch coming high again. And then once the limit switch has gone high again, we can see that the motor stopped in that position. So we can now position freely again without causing any faults. So we can turn off the reset fault bit. We can turn on automatic mode again. Let's send it to 0 millimeters. And then the enable bits are on, so let's send that. And the motor still has not moved, and that's because we need this start bit to actually cause automatic mode to work. So we need to send the start bit and then press send PA. And there we go. Now we are in position at 0 millimeters. Now let's just go ahead and deactivate our enable bits. And then send that, and then deactivate the other one. And then we can turn off all these bits and then send that, so that way the control word is currently off. Okay, that is everything that I wanted to show you with this new application module, positioning via bus. And you can see by controlling the MOVIDRIVE over a bus network, we have a lot more flexibility with our travel profile because we don't have to pre-program the movements. Now, to exit control mode, we need to just make sure that all the control word bits are off. We'll just go ahead and send a 0 speed and then a 0 target position, and then update that in the MOVIDRIVE by pressing send PA. And then now to exit into monitor mode, let's just click on to monitor mode. And we can see that we got the same error again about the controller inhibit terminal being turned on. So let's go ahead and press OK. And then now we need to go to our switch box and turn off the controller inhibit. And then now let's test going to monitor mode. And now we exited control mode properly and are back to monitor mode by switching the inhibit input off. And then we can also see that now the bus is back to Ethernet instead of being RS-485, which is our USB to serial converter cable. So what we can do now is just go ahead and press the cancel button to close this application module screen. And then let's back up these parameters to our project. So we will right click on our MOVIDRIVE, and then we will go down to manage unit parameter set, and let's say upload. This pop-up is warning us that it's going to overwrite the parameter file that is currently stored in the project folder, and that's exactly what we want to do. So let's press yes. And then now the parameters in that commissioning for the new application module is being backed up to our Motion Studio project. Since we're uploading over the serial cable, it will take a little bit longer. It's finished now, so we can go ahead and press OK. And we can make sure we save this project view by clicking on the floppy disk icon at the top of the software screen. So this concludes our lab demonstrating the bus positioning application module. We saw how controlling the MOVIDRIVE from a field bus was similar to the previous table positioning application, but this field bus based application module had more flexibility with the set point speed and positions, since we were able to do most tasks with the process data words instead of only having the digital inputs. The application modules that we have demonstrated in this training series are just an introduction into the capabilities of the MOVIDRIVE. We offer other application modules that are capable of more complex movements, such as multiple motor synchronization, rotary tables, winding and unwinding applications, and on-the-fly cut-to-length applications. There is also the possibility to create custom control methods by designing your own IPOS program. This is our final lab activity, so we have completed session 6 of this training series. In the next session, we will not be doing any demonstrations with the MOVIDRIVE or motor. However, we will discuss some common faults that can occur with applications that are controlled by motors and inverters. I'll also mention potential causes and some tips to help diagnose your application if you encounter those faults. Thank you for your attention. Take care and have a good day.